Welcome to real-time customer experience with Redis. And hopefully this is coming through all clear and clear as full. Okay, good. So, when I thought about how to present this and talk to how Redis would address this and how our customers are actually utilizing Redis for customer experience, I thought the best way to do this was to understand the functional requirements from a customer experience perspective and then map that to the technical requirements that are required to drive those functional requirements, and then we can match that to Redis and how we match those technical requirements. So that's what I'm going to walk through today. And I think this is a pretty obvious slide, right? But if we look at customer experience, we've all had some bad experience. It's very, very, very important that we get this right. In fact, I didn't realize till, looking at data points, but if you get this wrong, 89% of your customers will not return, okay? As well as you're going to damage your brand, you're going to definitely get cart abandonment, right? And this could be very, very simple things. I recently, I've got a DIY project at home, and I go to a well-known DIY company quite a lot. I use their website quite a lot, and I find it impossible to use their search facility. I put in light bulbs, I get padlocks. It's really, really bad. And also the recommendation system, where I'm trying to do a job, a DIY job, and I'm not an expert. So I want the system to actually tell me what other components go with this project. And then I would just put them to the cart and be very happy. But it doesn't. It's very random what it actually selects to put with the components I'm selecting. So my overall opinion and experience is very poor. So these are all things to bear in mind. And if we don't get this right, we will lose conversions, purchases, etc. So, a small show of hands, who's heard of Redis? Oh, that's not... You should put your hand up. Very good, very good. So, just going to have a quick 101 into what Redis is for those of you who haven't seen it before, and maybe some enlightenment around some of the new developments in Redis for those that are using it currently, because this is the mapping part of looking at the functional requirements and mapping them to the technical requirements of customer experience. So first and foremost, we are an open source platform developed by a lovely Italian person who's still with our company, and he develops the core platform that I'll show you today. But equally, Redis Labs, who look after that open source element, take that open source and we turn it into a mission-critical enterprise platform. So we add HA, scale-out, scalability, linear scalability, in fact, multi-geography replication, all of these mission-critical functions that large organizations require. We also add some additional functionality in the data types, which we'll talk about a little bit later on. So one of the things about Redis is, just to blow our trumpet a little bit, this was a report that was an analysis actually done by Sumo Logic, and they found out through their analysis that on AWS we are the most used database. And there's other accolades like Stack Overflow, who asked their community what is the most popular and loved database, and Redis came out, not just this year, but last year and the year before too. So we're very popular and very liked across all organizations. And there's a whole bunch of other accolades that go with us as well, which is lovely. One of the important ones is where we rank in the DB Engines website. So if you go to this website, it shows you by popularity and usage where databases rank. Redis is actually in the top 10 right now, and has been for many years. So, bit of a technical diagram here, so bear with me because this is the only way I could kind of work out how to flow this through. So I started with customer experience, And I tried to break down what that really means. So, and it depends what white paper you read or what approach you take. Some people think personalization is basic segmentation. Others actually have gone much further. So people like ASOS, for example, are really driving hyper-personalization through having their customers upload images of clothes that they like, and then ASOS will use an AI model to run against the image, understand what they like, build their profile, and then search their catalog for similar items or matching items that go with it. So this is really starting to become a new level of personalization. So for me, I just tried to break it down simply. It breaks into recommendations, offers, and profiles. And then moving from left to right, recommendations is really about understanding what content, what product to show the customer. And that can be done in a number of different ways. So I've tried to filter out here, okay, search is one way. You might want to just tap in, I'm looking for light bulbs, not padlocks. We see a lot of our customers using set theory. So being able to create a data set as a set, a list of items in a set, and then being able to compare and use set theory to analyze that set. One of our customers, Booking.com, is actually utilizing Markov chains. So I don't know if you ever heard of Markov chains, but they sit very, very nicely in a graph format. Moving into offers, I've put propensity to purchase here as one of the models, and in fact Bayes' algorithm as a simple kind of classifier that everyone starts with. But what I'm really talking about here and trying to drive is that ASOS kind of approach, right? The requirement to actually need a data model and an algorithm, some AI that really understands the data inputs and drives high-level personalization. So it could be a model that understands images, it could be classification algorithms, etc. The actual technical requirement is we need to have productionize our AI models. Profiles, these are becoming very important, obviously, as we go, especially with GDPR, etc. But being able to understand from historic engagements and interactions, what are the data points that our customers have been using and interested in. And this goes into user embedment, where we're actually looking at behaviors with our customers now as well. So there's a direct correlation between how our customers actually look at items in the website perhaps, and how they click on them or not click on them, or favorite them or save them to cart and then abandon them. All of these interactions are being tracked and in fact stored and reused, possibly by these models. But what this means is, from a technical perspective, is we have a set of high volume data elements that we need to ingest. We need some analysis, and also we need somewhere to keep this. Now, Redis is very, very commonly used as a session store, and what we're seeing now is our customers now building intelligent session stores. So they're adding the profile data into these session stores. Busy diagram, bear with it. So Redis is a key value database. It's in memory, it's built in C, it's very, very, very fast. And the key and the value is actually a data structure. Okay, so rather than a key value pair, the value pairing is a data structure. And there are about 225 operations that allow you to manage and manipulate these data structures. So we have things like strings. Okay, so you can store your web content pages in the strings. So one of the biggest use cases we have for Redis is cache. And you'll see at the end, people like Microsoft use us for caching because they have 2 billion hits over the, US poll week or whatever. We have hashes, a great flexible structure that is used for user sessions and profiles. We have lists, which are very good for order management, queues. We have sets. A lot of people build recommendation systems with sets, or they might use it for, Groupon use it for fraud identification, for example. It's a very, very fast, easy way to check for things like that. Sorted sets, just the same, but the elements in the set are actually ranked and weighted, so you can sort them very quickly. Geospatial, we have a couple of our customers, very large Home Depots on here later actually, and people like Gap, etc., who are using our geospatial technology in amongst mixture of these other data types to actually drive dynamic inventory from the website. So understanding whether they should pick up from store or warehouse delivery, etc. And streams. So streams is so we used lists for, which was one of our first data types in Redis ever, as a pub-sub model. And streams is the new evolution of that. So we've improved that, and that's a very useful for messaging and queues. So I mentioned about the open source and enterprise leveling, and the sets I've talked about are actually on this side. So this is all open source. What Redis Labs Enterprise brings you is the extension of that with other data structures and functions. So in the top left corner we have search, so a full text search autocomplete capability. The ability to store JSON documents and leave the JSON document and update elements of the JSON document in the database without having to retract it to the application and push it back again. AI. So when I mentioned about the requirement for an algorithm or a model, we have the ability to store TensorFlow models, PyTorch and Onyx, all within the database. The advantage of this is that you have a production time environment that you have your model in, and that gives you all the scalability, the performance, the high availability of the Redis database, but also it gives you a co-location with your data. Okay, and I'll come back to that a little bit later on as well in terms of why that's also important. So graph, we've implemented graph capability. So this is going back to Leonard Euler, 1736. Anyone aware of the graph theory? No? Anyone use graph? Okay, all right. You won't be wanting this one, no. So graph is very useful for fraud analysis, connected data basically. So you have a node and a relationship to another node. And they could be people, they could be products. It's very good for recommendation systems in content or collaborative analysis. So if you haven't thought about them, have a look at them. There are some really good use cases where it's very powerful. And the other ones I won't go into today, but if you're interested, come and see me later. Time series Bloom filter. Bloom filter is very good for fraud checking quickly and things like that. And of course, as I mentioned, underpinning this, the enterprise version gives you scale out, very, very high performance, linear scalability, high availability, durability, etc. For mission critical systems. Now, what I've kind of explained is the functional capabilities and the technical requirements for a good real-time customer experience platform. And one of the values of using Redis is that all of these functions and features that you require are actually all in one platform. So it saves you having multiple technologies and having to work out how to integrate them, pass data, induce latency because you're trying to chop data in and out, etc. It is deployable in any of the clouds or multiple clouds. So we can run multiple instances in different clouds and synchronize across clouds. You can run on-premise and you can run it as a hybrid between on-prem and cloud. in whatever one you wish to. So just coming back to customer experience from a speed perspective, there's some interesting points, and we always talk about, from a Redis perspective, because we're the fastest database in the world, why is that important? And we proclaim that most of the cycle time from your client to your application is taking up a network. So if you have a 50 milliseconds round trip each time, actually your processing time is very, very small. So if you don't have a database, an application that can process very fast, you're not going to hit the 100 millisecond delay time. Why is that important? So these figures are probably a little bit dated, and depending when, I think Amazon actually did this assessment about 10 years ago, to be honest. But so this 1% now is probably much bigger, right? Because they're taking over the world. But you can see the impact. So this is their own analysis of what a 100 millisecond delay would have on their business. In Google's terms, it was number of conversions, okay? And in Walmart, again, it's about sales. If you look at it from a website perspective, and this is taken from an Aberdeen Group analysis, and this now moves up a little bit more. So this is 1 second, but you're going to lose 11% in conversions, and 7%, which 7% in conversions, which if you're earning 100,000 a day through your website would be 2.5 million, just to put some, monetary figures on it. And you can see there, customer satisfaction just from 1% goes down by 16. So there is a need for speed here, right? And I mentioned Booking.com and their analysis. It is at this, it's very interesting. It's a run through of their analysis on their models that they use. And they, through interest, they wound up their latency to a point of 30% slower, which meant they lost 0.5% on conversions. So they found a direct correlation between the ability to actually run and deliver their model output. So this is very important if you're looking at running your AI models for customer experience. And it seems only fitting to follow that with our performance slide. So this is our latest benchmark. So we can operate at 200 million operations per second. Okay, and if you looked at, if you were here for the last session, so Revolut doing their their fraud transaction analysis, and they were at the 8 to 10,000 operations. We're ready for their growth, right? So we have some very large financial organizations running fraud systems using Redis who are, reaching towards these numbers. So we totally have the performance to provide real-time processing for your customer experience. So just to kind of round that all up, what does that really look like? So if you had all your Omnichannel piece over here, right? So whether the customers are mobile or on web or kiosk, the first thing you get is this massive influx of data. So you need to bring that together, the web activity, and understand what they're clicking on, user embedment, as I talked about, and mix that and join that with profiling. Now what you might do now is you might do some identity resolution, you might do some fraud checking, those kind of things. But you can run some analytics within the Redis database immediately. And then passing on your cleansed data to perhaps your AI model, which is understanding classification, what product to serve. It could be Markov chains in graphs for connected analysis, which you're all going to go away and read up on post this, I'm sure. And or it could just be a simple search, right? But all has to be really fast. And again, this can all be supplied with one Redis platform, serving the content. And I talked about Redis being a session store. over here, and now moving to an intelligent session store as well, with holding your customer profile data. Now this looks all very, it's all Redis, right? So you're just talking Redis, you've been drinking the Kool-Aid, but actually this is a slide from one of our customers called Dynamic Yield, and they are the leaders in the Gartner quadrant for personalization and recommendation. And you can see they have Redis all over the place in their solution, right? Because it is functionally rich and capable and very, very fast. I talked about MSN. We have a whole range of customers such as Visa, MasterCard, Amex, Wells Fargo, MSN on the media side, Warner Media, DreamWorks, AT&T, Verizon, Apple, etc. So everybody needs speed, or will need speed very soon. And Home Depot, these guys are really cool. They use a lot of our data structures for a lot of different things, geospatial being one of them, and I talked about dynamic inventory and that capability they're driving there, all in real time. So the customer is assured the delivery, but the product is where it says it is, either in store or will be delivered at a date in time. And I'm around after this. We have a stand here, and I have a technical guy with me too, if you want to get some real deep technical questions answered. Thank you.